Good morning, students. In previous video we discussed about law of triads, Newland's law of octaves and Mendeleev's periodic table, and we discussed their drawbacks also. Now next periodic table is modern periodic table. This is proposed by Moseley. This is based on atomic number. That means based on atomic number this periodic table is modified. This is discovered by Moseley. It is based on atomic number. In this periodic table 7 periods are present and 18 groups are present. 7 periods and 18 groups. Now we are using this periodic table. This is very big periodic table and very important periodic table. See, in this periodic table, first period contains 2 elements. First period contains 2 elements. That is why it is called shortest period, because it contains only 2 elements. Second period contains 8 elements. That is why it is called short period. Third period contains also 8 elements. That is why it is also called short period. Fourth period contains 18 elements. This is called long period. Fifth period contains it also contains 18 elements. That is why it is called long period. Sixth period contains 32 elements. That is why it is called longest period. And seventh period is incomplete period, because still some elements are going to discover. So this is the about modern periodic table. 7 periods. 1, 2, 3, 4, 5, 6, 7 periods. First period is shortest period. Second and third periods are short periods. Fourth and fifth periods are long periods. Sixth period is longest period, and seventh period is incomplete period. See, this is the periodic table, modern periodic table. See, in this one, this is first period. Periods are horizontal rows or periods. See, this is the first period. It contains 2 elements. 1, 2. Second period, how many elements? 8. 1, 2, 3, 4, 5, 6, 7, 8. Third period also 1, 2, 3, 4, 5, 6, 7, 8. From here to here, this is period. So these are periods. And vertical columns are called groups. Vertical columns 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. These are groups. Horizontal rows are periods and vertical columns are groups. So modern periodic table discovered by Moseley. It is based on atomic number. It contains 7 periods. Periods means horizontal rows, and 18 columns, nothing but 18 groups. You have to remember this point. 7 periods and 18 groups. Next, one more important point regarding this one. See, these first two groups, this is first group and this is second group. These first two groups are called S block elements. These are called S block. And these from here to here, that means from 13th group to 18th group, these are called P block elements. S block contains 2 groups. P block contains how many groups? 1, 2, 3, 4, 5, 6. P block contains 6 groups. Next, from 3rd group to 12th group, these are called D block. That means 10 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are called D block elements. And these two, lanthanides and actinides, these are called F block elements. These are called series, not groups. These are called series. So what is the point here? S block contains 2 groups. This is S block, this is P block, this is D block, this is F block. So S block is present at the left side of the modern periodic table. P block is present at the right side of the modern periodic table. D block is present between S and P block elements, and F block is present at the bottom of the periodic table. I repeat once again. S block is present at the left side of the periodic table. P block is present at the right side of the periodic table. D block is present between S and P block elements, and F block is present at the bottom of the periodic table. S block contains how many groups? 2 groups. P block contains how many groups? 6 groups. D block contains how many groups? 10 groups. And F block contains 2 series, lanthanides, not groups, 2 series, lanthanides and actinides. So these are the points. See, S block contains 2 groups, P block contains 6 groups, D block contains 10 groups, and F block contains 2 series. Next, there are some more points regarding modern periodic table. See, SDF block contains metals only. S block, D block, F block, and SDF, not P. SDF block contains metals only, but P block contains metals, non-metals, and metalloids. SDF block contains metals only, but P block contains metals, non-metals, and metalloids. That means most of the elements are metals. See, if you see this picture, then you get some idea. See, this green color indicates what? Metals. This yellow color indicates non-metals. This light pink color indicates metalloids. See, most of the elements are in green colors. That means most of the elements are metals. Very few elements are non-metals. That means very few elements are in yellow color. So these are non-metals. And this light pink color elements is considered as metalloids. So what is the point here? This is S block, this is D block, this is F block. All SDF block contains metals. P block, this is P block. From 13th group to 18th group, these are P block. P block contains metals, non-metals, metalloids. So what is the point here? Most of the elements are metals. One exception is there in S block. This is S block element hydrogen, that is gas. This is non-metal. This is non-metal. So only non-metal present in S block is what? Hydrogen. Hydrogen is a non-metal. See, this is in yellow color. Hydrogen is a non-metal. So what is the point here? Most of the elements are metals. Next, one more point. Here, this is the important point. Around the nucleus, we know this is nucleus. In class 9 we discussed all these points. Around the nucleus, these are shells. These are also called orbits. These are also called energy levels. These are shells. There are so many shells around the nucleus. These shells represented by 1, 2, 3 over R, K, L, M. We know all these points. Next, these shells contain subshells. Subshells, we know subshells means what? Subshells? S, B, D, F. These are called subshells. So shells contains subshells. That means subshells are present in shells. We cannot represent those subshells in this picture. Next, around the nucleus, shells are present. Shells contains what? Subshells. We discussed already now. S, P, D, F subshells. And those subshells contains orbitals. That means orbitals present in subshells. Then S subshell contains 1 orbital, P subshell contains 3 orbitals, D subshell contains 5 orbitals, and F subshell contains 7 orbitals. We discussed already all these points in class 9 structure of atom chapter. So around the nucleus, shells are present. Shells contains what? Subshells. Subshell contains what? Orbitals. Orbitals contains what? Electrons. We cannot represent all these points in this one picture. So what? Electrons present in orbitals. Orbitals present in subshells. Subshells present in shells. Shells are present around the nucleus. All these present in atom. I repeat once again, listen carefully. Electrons are present in orbitals. Orbitals are present in subshells. Subshells are present in shells. Shells are present around the nucleus, not in nucleus. Shells are present around the nucleus. All these are present in atom. That is structure of atom. So around the nucleus, shells are present. Shells contains subshells. Subshells are what? S, P, D, F. These subshells contains what? Orbitals. S subshell contains only one orbital. P subshell contains 3 orbitals. D subshell contains 5 orbitals. These boxes are considered as what? Orbitals. 1, 2, 3, 4, 5. And F subshell contains 7 orbitals. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And these orbitals contains electrons. That is about structure of atom. We discussed already all these points in class 9. I want to revise once again. I want to remind all these points to you. That is why I discuss now again. So this is about modern periodic table, and some more topics are there regarding this one. We will discuss those topics in next video. Thank you.